Hi everyone, welcome to CodeTav Management. So today we will solve the Geeks for Geeks problem of the day, which is insertion sort for the single linked list. So the question is given a single linked list. So you know right what is single linked list? So means there will be the address for the previous node will be stored, okay, to the uh, next node, means for the next node's address will be stored in the previous node's address part, okay. So no vice versa is there, only one directional, that is single linked list, right? So you need to sort the list in ascending order using the insertion sort algorithm, okay. So for that purpose you need to know first of all what is the single linked list, then what is the insertion sort algorithm, then you can apply those things, okay. So here the input is n equals to 10, means 10 digits are there. So 30, 23, 28, 30, then 11, 14, 19, 16, 21, 25, and output is in the sorted manner. Okay. So this is first example, and the second one is this one, right? So you don't need to read input or print anything, and your task is to complete the function insertion sort. So insertion sort is there. This is the insertion sort function. So it takes the head of the linked list. So node head reference, this is already present, and sorts the list using the insertion sort algorithm and returns the head of the sorted linked list, right? So your expected time complexity is big O of n square, and space complexity is or big O of 1. Okay. So here what we have done is first try yourself. Okay. Then you can take this approach according to your uh, purpose. Okay. So here the node insertion sort is there. So this function is there. So it's taking the head of the linked list. Okay. So what we have done is, like, we are checking. First of all, we are checking that the list is either empty or not. So we are checking that head ref is already null or not, or this the next for this head reference means or has only one node or not. Okay, so that's why we are checking like that only head node is present or not. First of all, we are checking this the head node is null or not, and after that we are checking that only head node is present or not. That's why we are checking that the next of that head ref is null or not. Okay, if so, then it means that the list is already sorted and the original head is returned. That's why we are returning the head ref only. Okay. Next, what we are doing, like, so initializes the sorted list to the null, okay, which will be used to build the sorted linked list, okay. And after that, it enters a loop that iterates through each node of the original linked list. So here you can see that current is there, right? So current is basically set to the current node, and head ref is moved to the next node, okay. So it checks if the sorted list means this sorted list is empty, or if the current node's data is less than or equal to the data of the first node in the sorted list. If so, okay, then we insert the current at the beginning of the sorted list, okay. Or in the other conditions means we will locate the node before the point of insertion. So that's why if not means it's not true, means this if condition is not true, then we are going into that else part. So if not the beginning means if not at the beginning, it iterates through the sorted list to find the correct positions, okay. That's why we are taking the temp, okay, to insert the current. And after that, what we are doing, like, means through this current next equals to temp next, and temp next equals to current. So here we are just completes the insertion by adjusting the pointers to include the current in the sorted portion. And finally, we are just returning the head of the sorted linked list. So basically, this function essentially performs the insertion sort by maintaining a sorted portion of the list and inserting each unsorted element into its correct position within the sorted portion. Okay, so this is the approach here. And for that means for that algorithm, as it maintains a sorted portion of the list and iterates through the unsorted portion and inserting each element into the correct position in the sorted part. That's why here the time complexity is big of n square and space complexity is big of 1. Okay, I'm just submitting it again to show that it's working or not. Yeah, so it's properly working. So try your approach as well. And if you have any question, you can comment down and just do like, share, and subscribe uh, for more such contents. Thank you.